Welcome back. We're going to look at another project here. This one, we are going to be creating a project that takes some input as a number this time, and then does some checks based on math. It's going to be if you can or cannot ride a roller coaster. Our roller coaster's got 3 different restrictions. Either you're over 160 centimeters tall, and you can ride this roller coaster with no restrictions, you can just ride it. If you're between that 160 and 80 centimeters, you can ride it with an adult. And if you're less than 80 centimeters, then you cannot ride a roller coaster. So let's write that as a quick comment at the top. More than 160 might be a bit tall. I'll lower it to 130. If you're between that 130 centimeters and 80 centimeters, you can don't. But if you are less than 80 centimeters, you here we have our 3 restrictions. What we're going to do is we're going to begin by asking the user how tall they are. We're going to save that as the word height, H-E-I-G-H-T. We'll call it rider height. We're going to make it some sort of input that they're going to respond to this question. How tall are you? And then I'm going to write cm in brackets so that they know to answer in centimeters. Put that space so that they don't edit themselves. By default, it thinks inputs are words, or as they call them in programming, they're strings. We need to make sure that this has been converted into a number, which in programming is called an int, which is short for integer. If I surround this input with int bracket, this means that it's going to try and turn whatever's inside of these brackets into an int, into a number. Let's just quickly print their heights. You are rider heights cm's tall. Let's run that. How tall are you? 183. You are 183 centimeters tall. So it's able to take our word and convert it into an int. Let's write something that's not an integer. Now it's got a problem. I've given it something that's not an integer. It's freaked out. It said it thought you were going to give me an int, but this isn't an int. It's a value error. We're not going to worry about this right now, but this is good to know that you can't convert everything into everything. We can try and turn a string into an integer, but some things, like the word dunno, it's not a number. It can't convert. Even if I'd written a number, like 5, it can't convert this, which is a word, into a number. Alright. Now, let us now continue. We've got our number being converted and saved as the rider height. let's do this check. We're going to check if, in this case, if the rider height is greater than 130 centimeters. In this case, we can print you are tall enough to ride the ride. Alright. What we're doing is three things. We are getting their height stored here, checking if it is greater than 130. These symbols here, there are five in fact, that we can use. They are this one, which from math we know is greater. You may have learnt that this is like a little crocodile or a Pac-Man. It's always trying to eat the largest object. So whatever is over here, it is trying to eat. You can also think of it as an arrow, and it's pointing towards the smallest thing. So either way, this is the greater than. In this case, whatever is here, it's going to be bigger than whatever is here. In that exact same vein, there's the opposite. This is for anything less than. In this case, whatever's here is going to be smaller than whatever's here, because the crocodile or the Pac-Man is trying to eat whatever's this side. We've then got a combination of that symbol and an equal sign. This means greater than or equal to. If we had 5 and 5 here, 5 is actually not greater than 5, because, well, 5 is 5. But if we had 5 and 5 in this situation, 5 is greater than or equal to 5. In fact, it's that equal to part. We've then got the opposite, of course, which is less than or equal to. And we've got one other one. The last one that we're not going to use today, but it is quite useful to know, is an exclamation mark equal sign. Exclamation mark means not. So not and an equal sign obviously means not equal to. We'll not be using this one today, but we will be using the rest for these. So if our rider, we're on this now, is 183 centimeters tall, you are 183 centimeters tall, this happens for everyone, and then you are tall enough to ride the ride. If they're only 60 centimeters tall, then we don't get this message because they're not tall enough. But what if they are exactly 130 centimeters? In this case, we don't get the message either. Now, based on our requirement, you have to be more than 130 centimeters. But it also says between 130 and 80 centimeters. So you can use your best judgment as to how you want to math this. In my case, I will allow you to be 130 centimeters, and you can still ride the ride. So now if your rider's height is greater than or equal to 130, and we say we're 130 centimeters, then we are still tall enough. Now we looked at these last time. These are else ifs. We want to check if you're between these two numbers. If your rider's height is less than 130, and I don't need to write 129 or anything, because this is once again checking less than, so 130 is 130, it won't be counted. If you're less than 130 and the rider height is greater than or equal to 80, we're checking two conditions now. One and another. In this case, both need to be true. This is our condition to say you may ride, but with an adult. Let's test this. We already know 180 will be you're tall enough to ride. Let's try and run it if we are 60 centimeters tall. Now this is too short for anything. And I don't get any other messages. Doesn't fall within our range. What if we're 130 centimeters? Because of this being greater than or equal to, 130 is allowed to ride. But what if we're only 120? We get our new message. You may ride, but with an adult. Probably should have said you must ride with an adult or something like that, but it still works. This falls within the category of less than 130 and greater or equal to 80. So if we are 80, we're still allowed to ride, but with an adult. Now we've got one other condition. We could do another LF. Let's say that LF, the rider height, is less than 80. This would be print. Sorry, you are too short to ride this ride. 60. Sorry, you were too short to ride this ride. 79. Sorry, you're too short. 80. You can ride. This works just fine, but what else would work here? Why would this work? What's happening is that we're checking, are you greater than 130? So this is every number up to infinity, which is bigger than 130. Else, are you less than 130 and greater than 80? So this is now checking every number greater than 80, less than 130, and over 130. So effectively every number greater than 80 up to infinity. In that case, else, or everything that's not being checked, is anything less than 80. So we can check this. We could just write else instead of having to do a last LF. Right. We're going to do one more project next, and that's going to be looking at a loop.